Good morning, everyone. We are Group 7, working on the case of Denver International Airport. I'm Shengying Wang. I'm responsible for the first part. In this case, I analyzed 4 external and 4 internal enterprise environmental factors. Next slide, please. External factors included political climate, legal constraints, market expectations. Internal factors involved change management failure, organizational structure, and human resource limitations. Next slide, please. Understanding these influences helps us see how project success depends not only on technical work, but also on the surrounding environment. Next slide, please. I learned from this case that even the best technical solutions can fail without good project management. The realistic planning and appropriate change management are significant to the whole project. We could also see that communication and leadership are just as important as engineer skill. In this case, many teams worked separately with no clear authority. This caused confusion and delays. A good project needs to bring all parts together. What's more, a good project manager must manage changes carefully. The baggage system was changed many times after designs were frozen, which caused rework and errors. Early awareness and anticipation of changes that may occur during project executing is an essential skill for project managers. All in all, I learned that enterprise environment factors are complicated and have a close relationship with the success or failure of a project. Project success is about the balance between technical goals and management systems. Leading a successful project is only possible when both are well executed. That's all. Thank you.
Hi everyone, my name is Honghua Zhang, and I will be responsible for the WBS. So here are some possible issues with the old WBS, including fragmented WBS and a lot of duplications, missing change control elements in the WBS, and missing critical quality verification steps. Next slide, please. Moreover, there is not adequate risk management integration, nor sufficient approval and oversight controls. Next slide, please. And here is the improved WBS for the project. Next slide, please. And here is the updated risk register as well as the next slide. And one important lesson learned from this project is the critical rule of a well-defined work breakdown structure for WBS. In large multiple-phase project like this, the WBS acts as the backbone of the planning, coordination, and control. However, in this case, the WBS either wasn't detailed enough or wasn't consistently enforced. As a result, key activities such as the structural changes, mechanical adjustments, and software development were not clearly tracked or linked to the milestone. Tasks overlapped and some deliverables weren't aligned with the responsibilities or scheduled updates. Frequent design changes occurred even after the construction began, which led to costly rework and delays. And the main takeaway is that a strong WBS should clearly break the project into well-scoped work packages, assign accountability to specific teams, and connect each task to budget, timeline, and risk planning. It should also be kept up to date as change happens. Without it, team operates isolated and communication breakdown, and small issues become major setback in the future. For any large infrastructure or technology-driven project, we should invest in more time upfront to develop and manage the WBS, which can prevent misalignments later and help the project to stay on track even under pressure. Thank you, that's all.
Hi everyone, I'm Lu Zhang. I'm going to introduce network diagram and Gantt chart. First, I imported our full WBS into Microsoft project. After discussing as a team, we finalized the predecessor relationships to build the logic between tasks. To meet the project deadline, I adjusted the timeline and added key milestones and cleaned up Slack issues. Next slide, please. Here's the full Gantt chart. Next slide, please. This is our network diagram, which shows how all tasks are logically connected. Next slide, please. One important lesson I learned in this project is that a WBS is not a schedule. At first, our WBS looked complete, but once we put it into Microsoft Project, we noticed huge slack values simply because we didn't set logic links or milestones. That's when I realized the structure is important, but without time logic, it doesn't mean anything. That brings me to the second lesson. Milestones are essential. Once we added milestones to break the project into clear phases, we were able to limit task floating and track whether each stage was on time. Without them, it's very easy to lose control of the timeline, and we almost did. Lastly, I learned that software is a magic. Even though software can calculate dates and draw a diagram for you, it can decide what's logically correct. It's still up to us as engineers to understand the dependencies and make judgment calls. Otherwise, the system gives you something that looks correct but isn't useful. These lessons really help me see the value of scheduling, not just as a technical tool, but as a way of thinking. Thank you. That's all.
Hello everyone, my name is Cao Li. I'm responsible for question for meaning about change management. This project was about building an automated baggage system for Danforth Airport. Originally, each airline had its own system, but part of the way through, the city switched to a single centralized system for all terminals. The big change, along with last-minute airline requests and poor communication, led to serious problems, delays, cost overruns, and system failures. To avoid this, in the next slide, we will apply Kotter 8-step change model, including create urgency, build a strong team, make a clear vision, share the vision, remove the roadblocks, show small wins, keep improving, and make it stick. Finally, what we lesson learned from the change management in the next slide is about firstly, scope changes must be measured. Standard large changes like moving from decentralized to centralized design need structural evaluation and impact assessment. Without it, team lose direction. Secondly, late requirements are risky. When stakeholders bring it request late, it creates rework and increases the risk of falling. Clear timelines for requirement submission are essential. Third, political pressure can harm technical integrity. Deadlines imposed for political reasons rather than readiness can force systems to launch unfinished. Engineers must push for realistic schedules. The last, immature technology needs testing. New tech may seem exciting, but without full-scale testing, it can be trusted in mission-critical systems. Applied testing and validation are key for this project. Thank you.
Hi, I'm Hongru Wang. I'm going to talk about the risk management. The Denver International Airport project reviewed critical weaknesses in risk management. Many high severity risks, such as incomplete system testing and unproven new technology, were addressed too late. With no unified project manager and 200 plus separate contractors, nobody could control risks across the whole project. Some risks, like labor disputes and power issues, were foreseeable but not properly mitigated. Others, such as frequent design changes and work size conflicts, are a result of poor project coordination. The risk table is shown here. More detailed description is provided in the report. One of the biggest lessons from the Denver airport case is that integration is not just the final step. It should be managed from the beginning. In this project, parts like sensors, software, and even labor teams were designed and tested separately. Each part worked on its own, but when everything came together, the system failed. This teaches us an important lesson for any industry. No matter how well each part performs, the real success depends on how well they integrated. Whether you are building an airport or launching software product, integration between systems, people, and timeline must be planned early and carefully. You can't just wait until the end and hope everything fits. That's what went wrong in Denver. Future engineers and project leaders need to treat integration as a major risk that needs early planning, joint testing, and to mitigate. In the end, it's not just about building good parts, it's about making them work together. That's a real challenge. That's it for our presentation video.